Smoke testing is a type of software testing that verifies whether the basic and critical functionalities of an application are working as expected. It serves as a preliminary check before proceeding with more extensive testing, acting as a gatekeeper to ensure that the build is stable enough for further testing phases. Key aspects of smoke testing. Objective: to ensure that the critical paths of the application are functioning correctly. If the smoke test fails, further testing is halted until the major issues are resolved. Scope: focuses on verifying key functionality, such as application startup, basic UI elements, critical business flows, and core feature accessibility. Frequency: typically performed whenever a new build is deployed, especially in continuous integration/continuous deployment, CI/CD, pipelines. Quick feedback: provides rapid feedback to developers about the build quality, allowing early detection of major defects. When to perform smoke testing. After each new build or deployment to ensure basic functionality works. When integrating new modules into the application. After bug fixes to validate that the core application remains stable. Types of smoke testing. Manual smoke testing, conducted manually by testers to quickly validate the core functionality. Automated smoke testing, uses automated scripts to validate critical paths, often integrated into CI/CD pipelines for faster feedback. Steps in smoke testing. Identify critical tests, focus on the most crucial and frequently used functionalities of the application. Set up test environment, ensure the environment mirrors production as closely as possible to catch potential integration issues. Execute tests, run the identified smoke tests to verify the application's critical paths. Analyze results, document any failures and log them for immediate review and resolution. Decide go/no-go, if smoke tests pass, proceed to more in-depth testing. If they fail, the build is rejected until fixes are made. Tools for smoke testing. Selenium automates browser-based tests and can be used for web application smoke tests. PyTest, Python-based framework that is highly extensible and useful for writing simple smoke test scripts. JUnit/TestNG, common for Java applications, integrating easily with CI/CD pipelines. Postman, for API smoke tests, validating that endpoints are accessible and functioning. Jenkins, CI/CD tool that can run automated smoke tests as part of the deployment pipeline. Best practices for smoke testing. Keep it simple, focus on high-level, critical tests that ensure the build's key functionality is operational. Automate where possible. Automation helps in quick execution and integration with CI/CD pipelines, speeding up feedback. Rapid execution. Smoke tests should be quick to run, typically taking only a few minutes. Maintain test suites. Regularly update smoke test cases to reflect changes in critical application functionality. Document failures. Clearly log any failures and provide enough detail to help developers quickly identify and fix issues. Example of smoke testing using PyTest, Python. Here's an example of how to write a simple smoke test in Python using PyTest and Selenium for a basic web application. #test_smoke.py. Import ptest. From Selenium, import WebDriver. Add ptest.fixture. Def setup. Driver equals webdriver.chrome, #. Make sure to specify the correct driver path. Driver.get, https://example.com, #. Replace with the actual application URL. Yield driver. Driver.quit. Def test_homepage_loads, setup. Driver equals setup. #check if the homepage title is correct. Assert welcome to example in driver.title. Def test _login _page accessible, setup. Driver equals setup. Hashtag click on the login link or navigate to the login page. Driver.find _element by _ID, login link, click. Hashtag check if the login page loaded by looking for a known element. Assert driver.find _element by _ID, login button, is displayed. Def test _core functionality, setup. Driver equals setup. Hashtag example of checking a core functionality like searching. Search _box equals driver.find _element by _ID, search box. Search _box.send keys, test query. Search _box.submit. Hashtag check if the results page loads correctly. Assert search results in driver.page _source. Explanation. Fixture setup. The setup fixture initializes the browser session and navigates to the application URL. Homepage test. Verifies if the homepage loads correctly by checking the title. Login page test. Checks the accessibility of the login page by clicking a link and verifying a key element. Core functionality test. Ensures basic operations like a search feature work as expected.